asteroids are dark. They're charcoal black in most cases, and that means they're hard to see in optical light. They don't reflect a lot of light, right? Picture a charcoal briquette out in space. You cannot spot asteroids very well from the ground using optical telescopes from very far away. And that's why we've only discovered less than 1% of the ones that could destroy a city. So you can use that fact to your advantage though, because if they're dark, they absorb a lot of sunlight, they warm up, they're brighter than the background in infrared. Okay? Now, if you want to observe in infrared, you have to go into space because our atmosphere absorbs these wavelength bands of infrared. You can't see them from the ground. So therefore an infrared space telescope. And as to where you want to put it, you want to be somewhere where you can see Earth's orbit with your back to the sun. And therefore we're putting it in an orbit around the sun, very similar to the orbit of the planet Venus. The B612 Sentinel mission is privately funded. You don't have to ask people's permission. You don't have to worry about political deals. You don't have to worry about the nuances of how things go through government funding. You can just do it. Now, why have private donors stepped up to fund these types of things? Because they want to see us advance science, advance the state of the art, discover new things, and with Sentinel, you have the added benefit that you could save the world. I mean, what's not to love about that? Mm-hmm. In fact, I don't know if you know this, but more than half all the successful interplanetary missions ever flown from planet Earth have been either managed or had someone on our team be in a key role in over half of them. And we can do this. It is difficult. I mean, don't get me wrong, this is an interplanetary space telescope. That's never been done before. But we have a team that can do this.
Space.com